Hello everyone, today we have to study about the drug clearance through the metabolism. Before this, we already done how the drug is going to be administered into the body. Then after that, we study about the drug absorption. Today we have to study about the drug clearance after the absorption, after distribution. So whenever the drug is going to enter into your body, it will move toward the kidney. And if it is present in the lipophilic form, it is going to be excreted through the urine. But if the drug is present, if it is present in the hydrophilic form, it is going to be excreted through the urine. And if it is present in the form of lipophilic, in the lipophilic form, it is going to reabsorb from the distal convoluted tubules. So now the body have to do, it have to convert the drug into the hydrophilic form. So it will enter into the liver and convert into the metabolites to the enzymes. And if the metabolites are active, then they are going to perform their desired action. And the inactive metabolites are going to be excreted through the urine. Now we have to discuss about the kinetics of metabolism. There are two kinetics, the first order and the zero order kinetics. First order kinetics are also known as linear kinetics and they depend upon the concentration, whereas zero order kinetics are known as non-linear kinetics and they are independent of concentration of the drug. First order kinetic, as we can see in the equation, V is the rate of drug metabolism, Vmax is the maximum drug metabolism, C is the concentration, and Km are the Michaelis-Menten constant. Now you can say Michaelis constant. If C, concentration of drug, is much less than Km, then we can write this equation as it is written here. V is equal to rate of drug metabolism is equal to V max into C concentration over Km. This is the rate of drug metabolism is the directly proportional to the concentration of the free drug and the first order kinetics are observed. This means that a constant fraction of drug is metabolized per unit of time. Zero order kinetics. There are some drugs like aspirin, ethanol, and phenytoin. The doses are very large. We can't neglect concentration. So C is much higher than Km. So we have to neglect Km. Now, rate of drug metabolism is directly proportional to V max, mean it is independent of concentration. What we have to do, we have to just cut down this C and this C. The rate of drug metabolism is directly proportional to V max, not on the concentration. So the zero order kinetics is independent of concentration of the drug. The next thing we have to study about the reaction of the drug metabolism. As I told you before, if the drug is lipophilic in nature, it is going to reabsorb from the distal convoluted tubules back. So what we have to do, we have to convert, or our body have to convert the lipophilic drug into the hydrophilic drug so it can be easily excreted through the urine or through the liver in the form of the bile. So it requires two sets of reaction, phase 1 and the phase 2 reactions. First is the phase 1 reaction. The phase 1 reaction involves P450 system and CYP type is the superfamily of heme containing isoenzyme. The drugs, there are a lot of drugs that are going to convert themselves to the phase 1 reaction. For example, steroids and the lipids that are lipophilic in nature. So for the conversion of these into the hydrophilic form, we have to pass them to the phase 1. You can see here in the diagram, the drug have to pass to the phase 1. So in the phase 1, oxidation, reduction or hydrolysis will occur and convert the drug into the hydrophilic form. And in the phase 2, some drugs pass from phase 1, and if they are not completely hydrophilic, then they are going to enter into the phase 2 reaction where the conjugation will occur. And there are some drugs which are directly move into the phase 2 without passing through the phase 1. Now we have to talk about the inducers and the inhibitors of cytochrome CYP450 enzymes. Before that, we have to discuss about CYP. What is it? I told you before, CYP system, or you can say CYP is a subfamily, and other are the next thing is four, for example, 450 or CYP3A. So the next capital letter show the after the number is the show the subfamily, and if there is any other number 4 or 5, it shows the isoenzyme. You can say it's the isoenzyme. A show the subfamily. Hope so it's clear. So there are some inducer and some inhibitor of these enzymes, these isoenzymes. There are different families. Today we have to talk about first about inducers. Inducers are the isoenzyme. They are going to induce the enzyme. Inducers are the drugs that are going to induce the isoenzymes. And when they are going to induce, mostly it will decrease the pharmacological effect of the drug. For example, rifampin is an anti-tuberculosis drug. What it is going to do, it will decrease the concentration of HIV protease inhibitor by increasing the level of isoenzyme. When the level of isoenzyme is going to increase, HIV protease inhibitor is going to decrease, due to which it will not suppress the HIV. And here are some consequences of increased drug metabolism. It will decrease the plasma drug concentration because it is going to increase the level of isoenzyme. Second, it will decrease drug activity if metabolite is inactive. What is the function of enzyme? They are going to break down it or metabolism, done the metabolism of the drug. And if after the metabolism the metabolite is inactive, then the drug activity is going to decrease. But if the metabolite is active, then the drug activity is going to increase. The fourth one, decrease the therapeutic drug effect. The next thing is the mnemonics for the inducers. The next thing we have to discuss about the inducers, there is a mnemonic bullshit crap GPS. So what we have to use, B, the highlighted part, B from the bull, S from the shit, and crab GPS. Barbiturate, St. John wort, carbamazepine, rifampin, alcohol, phenytoin, glycoflavin, phenobarbital, and sulfonylurea. These are the drugs that are the inducers that are going to produce or increase the level of the enzyme in the body. The next thing are the inhibitors. Inhibitor of CYP isoenzyme lead to drug interaction. Inhibition through competition for the same enzyme. For example, if there are two drugs, for example, omeprazole and warfarin, they both need the same enzyme for the metabolism. So what is going to happen? For example, omeprazole, it is going to increase the level of CYP, or they are going to not increase the level of, they are going to act on the CYP isoenzyme, on the specific isoenzyme. Now there is no free enzyme for the conversion of warfarin into the its metabolites. So what is going to happen? Warfarin level is going to increase, and we all know that warfarin is used as an anticoagulant drug. So now what is going to happen? If the warfarin level is going to increase, it is not going to convert it to metabolite or not going to metabolize, then it can cause bleeding. Other than these drugs, there are some natural substances like grapefruit that also inhibit CYP3A4 and lead to high level of drugs such as nifedipine, clarithromycin, and simvastatin that are going to be excreted through the CYP3A4 or going to metabolize through CYP3A4 system. Here is the mnemonics for inhibitors, sickfaces.com. Sodium valproate, isoniazid, C. cimetidine, K. ketoconazole, F. fluconazole, A. Alcohol like drinking alcohol, not the too much alcohol or chronic use of alcohol. C. chloramphenicol, erythromycin, sulfonamide, ciprofloxacin, omeprazole, and metronidazole. Phase 1 reaction not involve the P450 system. These include amine oxidation, for example, oxidation of catecholamine or histamine, alcohol, dehydrogenation, for example, ethanol oxidation, X-rays, for example, metabolism of pravastatin in liver, and hydrolysis, for example, protein. So there are some drugs which are not going to involve P450 system in their metabolism. The next phase is the conjugation phase or phase 2. The drugs which involve mostly the drugs which are not going to be completely convert themselves into hydrophilic form, they enter into the phase 2. But some drugs are here which are directly involved into the phase 2 reaction. So the drugs containing OH, NH2, COOH, they directly enter into the phase 2 without passing to the phase 1. Thank you so much. If you have any question now, you can ask.